Good afternoon friends, and welcome again to another session of Parijat sir classes. Today we are going to discuss some very good numericals of class 11 topics. Okay, so as you can see, today I am going to discuss with you physics numericals of class 11. Today's session will be of class 11. I will deal only with the physics numericals, and the topics you can see: center of mass, moment of inertia, rotational motion, and work, power and energy. These are certain important topics which I am going to discuss with you, some very good numericals. So please keep watching the full video to get some concepts of very good numericals of this topic. So as you know, you are watching Parijat sir classes. Please like, share and subscribe my channel so that more and more important and interesting videos can be uploaded for you. So let's get started. Okay, so the first sum, it is assumed that you know a little bit concept of these topics, and if possible I will start to give you some concepts also which will be helping you to solve the numericals. Okay, so let's get started. This sum is about center of mass. So find the center of mass of three particles at the vertices of an equilateral triangle. Okay, so there are three particles whose masses are given to us as 100 grams. The masses of the particles are given to us as 100 grams, 150 grams, 200 grams, and the side of the equilateral triangle is 0.5 meters. So this is the equilateral triangle, as you can see, and we have to place the triangle in such a way so that we can estimate the coordinates of the triangles. So let one vertex be at the origin, so it is 0, 0. One vertex at the x-axis, and you know that the length of the side is given 0.5, so this will be 0.5 comma 0. And now the coordinate of this, so this is half of 0.5, so this is 0.25. and what is the height of this? The height of this will be root 3 by 2 into side, root 3 by 2 into side, which is this, root 3 by 4. So this is the coordinate of the vertex B. Okay, so let the mass, first mass located here is M1, M2 and M3. So let us find the center of mass. So center of mass, let the coordinates of the center of mass be x comma y, and you know that center of mass coordinate is written like this: x equal to m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. So this is the m1 and x1 is 0, m2 and x2 is 0.5, m3 and x3 is 0.25 by m1 plus m2 plus m3, which is coming 5 by 18 meters, 5 by 18 meters. Similarly, let us find the y coordinate of the center of mass. The formula is given to you. So this is m1 into y1 plus m2 into y2 plus m3 into y3 plus by m1 plus m2 plus m3, which is coming, this y is 1 by 3 root 3 meters. So the center of mass lies at this coordinate. Center of mass will lie at this coordinate. Clear? Let's see the next sum. The next sum says a body moves from point A to B under a force. Find the work done. So this is work done. Work done, as we know, is force into the displacement, and if the force is plotted on the y-axis and displacement under the x-axis, so work done will be the area of the graph. It will be the area of the graph. So let us see, this is the force and this is the displacement and this is the graph. So work done by a body from A to B is the area under the graph. So as you can see, I have marked the areas. This is 1, 2, 3, 4. So what is the area of 1? It is a rectangle. So it is length into breadth. So it will be 10. The length is 10 into breadth is 1. So 10 into 1. Next is a trapezium. So half into sum of the parallel sides. So one parallel side is 10, another parallel side is 15. So, and the distance between the parallel sides is 1. So this is the area of the trapezium. Third one is a triangle, half into base into height. So base is 1 and height is 15. And next it is on the negative side of the negative side. The force is on the negative side. So that means the area will also be subtracted. So area of the fourth part is again a triangle, half into base into height. Okay. So now if we add all these, we are getting the total work done will be 22.5 joules. This is how you find the work done under the force and displacement graph. Find the area. Next, a particle moves from, this is the initial point to this final point. Okay. And the force is given to us. Find the work done. So work done is a scalar quantity F dot S. Work done is a scalar quantity F dot S. So this is my F, and we have to do the dot product. We have to do the dot product, and this is from A to B. So what is the displacement? This B minus A. So this is the displacement, and now we have to do the dot product of these two vectors, and we know in dot product I square equal to j square equal to k square is equal to 1, and I dot j, j dot k and k dot I will all be 0. So we will only take I parts, that is 4 into 11 is 44, then 1 into 11 is 11, and then plus 3 into minus 3 is minus 9. So this is the total work done by the body. Next friends, let's see the sum. Next sum. A particle of mass 0.5 kg, so this is the mass given, travels in a straight line with a velocity of this. See, this is the velocity 5x to the power 5 by 2. Okay, velocity is given like this, where x is a variable. How much work is done by the force during the displacement from x equal to 0 to x equal to 2. So now when the body is at x equal to 0, when the body is at x equal to 0, we know that the velocity, initial velocity is 0. And when the body is at x equal to 2, we know that the velocity will be 5 into 2 to the power 5 by 2. This is the velocity of the body when it is x equal to 2. So we know that the velocity is changing. That means the work done will be change in the kinetic energy. So this is the thing, half m is common. So this square minus this square, okay, it is v2 square. It should be v2 square. It should be x2. v2 square minus v1 square. So this will be 2 to the power 5 minus 0 to the power 5. Okay. So from here we calculate and we get this is the answer, because velocity is changing. So here it will be change in the kinetic energy. Next sum is about collision. Next sum is about collision. There are two bodies A and B. So this is A and B. The mass of both of them is m. Please note that the mass of both of them is m. A is moving along x-axis with 10 meter per second. As you can see, A is moving along the x-axis with 10 meter per second, and B is at rest. So this is the body B at rest. After elastic, so what type of collision? Elastic collision. A gets deviated at 30 degrees, so this is the direction A goes. Okay, what is the direction of B and the speed of two bodies after the collision? Please remember this thing. When two equal masses, so we know that we have taken both the bodies of mass m, collide elastically, please remember this, and one of them at rest, so B is at rest, remember it, after collision both the bodies should move at 90 degree to each other. Please note that. In elastic collision, if both are same masses and one is at rest, after collision they will be moving 90 degree to each other. So if this is 30 degree given, this phi should be 60 degree, so this should be 60 degree. Now in an elastic collision, momentum is conserved, that is momentum before and after is same. So what is the momentum before? M into 10 plus this will be 0 because B is at rest, and let the final velocity be u and v. So it is mu cos 30. As you can see, this component has horizontal component u cos 30 and vertical component u sin 30. Similarly, v has a horizontal component v cos phi and vertical component v sin phi. Already we know the phi. So it will be mu cos 30 plus mv cos 60. Okay, for the body B it will be mv cos 60. This is the horizontal component. Putting the values, this is m into 10. We know that m will be cut out from both sides. So it is 10 equal to root 3 by 2 u plus v by 2. So root 3 u plus v equal to 20. Okay, we know till here root 3 by v equal to 20. So let us highlight this equation. First equation we got till here. And next we know that the vertical components mu sin 30 will be equal to mv sin 60. They will cancel each other. Okay, so m and m cuts, u by 2, sin 30 is half, sin 60 is root 3 by 2. So u is coming root 3v. Now putting the value of u in this equation, we get this. So ultimately we can find out the value of v, which is coming 5 meter per second. That means B moves with a velocity of 5 meter per second at an angle of 60 degree. Okay, and since u was root 3v, so this is the value of A. So A will move with this velocity after collision at an angle of 30 degree. Clear? Let's see. A bullet of mass m, this is the bullet of mass m, moving with a velocity v, this is the velocity v, it is moving, is embedded into a block of mass m. It gets embedded, it keeps inside, embedded, it gets embedded inside the block of mass m. That means initially it was m and now finally it will become m plus m. Now with that embedded bullet, the block rises to a height h. The block is rising to a height h. Question is, prove that the velocity of the bullet was this. Okay, you have to prove that this velocity is actually this. Okay, so please watch one thing. The momentum, according to the conservation of momentum, the momentum before collision was m into v, and momentum after collision, let the velocity with which this moves, let the velocity with this moves is v1. Okay, so what is the momentum before collision? This. And momentum after collision is total mass is this. Let the velocity of movement be v1. So this is the velocity with which the block will rise up This is the velocity with which the block will rise up. So kinetic energy is converted to the potential energy. Okay, so what is the initial kinetic energy? This is the initial kinetic energy. Total mass is m plus m into v1 square, and potential energy will be m plus m into g into h. So from here we get v1 square is 2gh. Now v1 is mv by m plus v. Okay, so squaring both sides, so squaring both sides, as you can see that we have to square v1 square. So this is the v1 square equal to 2gh. So from here we calculate v square is this, and this is the formula thing we have derived. So this is the final derivation of the velocity. This is the derivation of the velocity. Clear? So friends, next, let's see the next sum. A chain of frictionless table with 1 by nth of its length hanging over the edge. So see, 1 by n of the total length. The total length of the chain is L. That means L by n part will hang down. So this is the L by n part hanging down. Okay, and total mass of the chain is m. So they are telling how much work is required to pull the hanging part back on the table. I want to pull this part up on the table. What work should be done? Okay, so we know that the total mass is of the length L. So what is the mass per unit length? So what is the mass of this much L by n part? It will be m by L into L by n. So this is the mass of the chain which is hanging down. Okay, so how much is the chain hanging down? L by n. So we know the center of gravity of that lies at the middle. So the total mass m by n, total weight will be lying at the center of gravity, which is at a distance of half of this, which is L by 2n. So if I can lift this center of gravity up, that means my work will be done. Mass of the whole of this hanging chain is at the center of gravity, and center of gravity is half of the distance of the hanging, which is L by 2n. That means the total mass is actually hanging at L by 2n. Okay, so work done is force into displacement. So what is the force I will apply? The force is this weight I have to carry up. This is the weight I have to carry up through a distance of L by 2n. So this is the answer, mg L by 2n square. This will be the answer of this sum. Next, a 1 kg block is connected to a spring constant this. So this is the spring whose spring constant is given to us as 100 Newton per meter. Okay, and a block is resting here. So this is the block which is resting here. This is that block which is resting here. Okay, so now we can easily see that the directions of the force which is given here, please watch here, the weight of the block will be hanging down. Clear? And if this is 37 degree given, so this is also 37 degree, this is 37 degree, so this is mg cos 37, and this is the reaction force of the surface on the block. Clear? And this is mg sin 37, which will act on this side. And if there is a frictional force, F will be mu into R acting up. The frictional force is acting up. So now they are telling that the block slides by 10 centimeter and comes to rest. That means the energy possessed by the spring is actually the work done. Okay, so now let us see this sum. Find the coefficient of friction. So watch here. First of all, as you can see, the force acting down is mg sine 37 and the force acting up is mu into r, the frictional force. So the net force which is downwards is actually balanced by the spring's force. The spring's force we already know is kx. Okay, this net force is actually given by the spring force. So putting the values, and sine 37's value we know, so we can find out the coefficient of friction. We can find out the coefficient of the friction. The spring is extended by 10 centimeter, so the force will be k into x. K I know, x is 10 centimeters. So this is the force applied by the spring, due to which the net force is balanced, and then resolving the forces we can put the values and calculate. Okay, sine 37's value is this, sine cos 37's value is this. So putting the values we calculate the coefficient of friction. Next, let's see the next sum. A massless platform, so this is the massless platform, is kept on a light spring. A stone of 0.1 kg is dropped on the pan from a height of 0.24 meter. So this is 0.24 meter, 0.24 meter is the height, and the spring gets compressed by this. So this is the x part which is getting compressed. The spring is getting, from what height should the stone be dropped to cause a compression of this? First of all, it is getting compressed due to this. So the potential energy of the body, of the mass, is actually stored in the spring. So spring's potential energy we know is this, and body's potential energy will be this. So potential energy by the body is transferred to the potential energy of the spring. So m I know, g I know, h I know, k I don't know. So x square I can find, x I know, so k I know. Spring constant of the spring I know. Now they are telling from what height. So let the height be h dash. I want a compression of 0.04 meter. That means again the potential energy of the body is equal to the potential energy of the spring. So m I know, g I know, h dash I don't know, half into k into x square, the distance of compression I know. So from there h I dash I can calculate that I have to drop it from a height of 3.84 meter. Next, it is again a sum of the center of mass from a uniform circular disc. So this is a circular disc, as you can see. This is a circular disc of radius r. Another disc of radius r by 6, and at a distance of r by 2 from the center is cut out and removed. Find the center of mass of the remaining portion. Okay, so this was the total circular disc. From this, another disc of radius r by 6 at a distance of r by 2 from the center is cut off and thrown. So what is the center of mass of the remaining system? Okay, so we know that since the disc has been cut on this side, so center of mass will shift on this side. Clear? So let the center of mass be shifted to the distance x. Let the center of mass be shifted to a distance x. So now watch here. We know that the total mass of the disc is m of radius r. So we can take mass per unit area. So what was the mass per unit area? M by pi r square. So for the smaller area of radius, this is the area of the smaller disc, pi into r by 6 whole square, pi into r by 6 whole square. This is the mass per unit area. So what is the mass of the smaller disc? It is m by 36. M by 36. So let us see. we know the center of mass will shift on the other side. So x is equal to the mass into the 0, because the total mass of the initial disk was at the center. Okay, and now this smaller mass, which is this much, is r by 2 distance away from the center, r by 2 distance away. And this is, and since why we are taking negative, we are taking negative because this mass is removed from here, that is why minus. If it is added, then plus. This mass is removed, that is why we take a minus sign here. This is the minus sign here, m1 plus minus m2. Solving it, we get minus r by 70. Now what does minus suggest? Minus suggests that if you have cut it on this side, your center of mass will shift on the other side. It means this. It means this only, that your center of mass will shift to the other side. Next sum, let us see. Find the center of mass. Find the center of mass of a uniform L-shaped lamina with dimensions shown. The mass of the lamina is 3K. So this is the mass of the L shape. This is the L shape. It is divided into 3 equal squares. So each mass will be of 1 kg. Each of the mass will be 1 kg, 1 kg and 1 kg. Now let the sides of the dimensions are given here. Yes, the dimensions, let the dimension of this part be 2a. So this is 2a. So this is a. This is a. This is a. That means this part is a. This part is also a. This part is also a. And this part is also a. So what is the coordinate of Q? What is the coordinate of P? The x of P will be a by 2 and y will be a plus a by 2. This is a by 2. This is a by 2 plus a. So the y coordinate will be a plus a by 2, 3a by 2. Now come to Q. The x of Q is a by 2 and y is a by 2. So a by 2 comma a by 2. Now come to R. What is the x coordinate of R? It is a plus a by 2, a plus a by 2, which is 3a by 2, and y coordinate is a by 2. Now let us find out the x coordinate of the center of mass. So each part is 1 kg. So 1 into the x coordinate of P plus 1 into the x coordinate of Q plus 1 into the x coordinate of R by 1 plus 1, m1 plus m2 plus m3, and this is the x coordinate of the center of mass. Similarly, if I take the y coordinate, it is, for the P it is 1 into the y coordinate of P plus 1 into the q coordinate of y coordinate of Q plus 1 into the y coordinate of R by m1 plus m2 plus m3, and this is this. And supposing a is 1, if I take a as 1, so the coordinate will be 5 by 6 comma 5 by 6. So this is that center of mass. Clear? Next, consider a 2-particle system with particles of masses m1 and m2. There are 2 particles of masses m1 and m2. The first particle is pushed towards the center of mass through D. Okay, so this particle, let the center of mass, because the masses are different, we know that m1 is not equal to m2. Okay, so center of masses are not same. So let the center of mass be at a distance x from first mass and at a distance of y from the second mass. Okay, so what was the initial center of mass? This m1x plus m2y by m1 plus m2. Okay, and now when the first mass is shifted by a distance d, The first mass is shifted by a distance d. So now it is here. So what is the distance left now? X minus d. Okay, and let this mass is moved and its distance from the center is k, because they are telling center of mass will remain same. Center of mass will not shift. So if I move this by d, how much will I move this? That is the question. How much will I move this? So let the new position of the second mass be k. The position of the first mass will be x minus d. Okay, so let us find the x coordinate of the center of mass. It will be m1 into x minus d plus m2k will be m1 plus m2, and they are telling center of mass is at the same position. Okay, that means whatever was the x before, the x after is all both same. So equaling it, we calculate the value of k. Okay, now this is the new position of the second mass. Its old position was y. So by how much has it been moved? It has been moved by y minus k. It has been moved by y minus k. So let's see. So y minus k, and we calculate it, it is coming minus m1d by m2 on the other side. That means I will move on the other side. If this is moved this side, I will move on this side. If m1 is moved on this side, m2 will be moved on this side. That is what they are telling by the minus sign. Next sum. There is a non-uniform bar. Please see this. This is a non-uniform bar of weight W. So this is the bar hanging weight, and it is suspended by two strings making angle 36.9 degree with the wall and 53.1 degree with the wall. The bar is 2 meter long. Find the distance d of the center of gravity of the bar from the left end. Okay, so please watch here. Let the tension in the strings be T1 and T2. So this is T1 cos 36.9 degree, and this is T1 sin 36.9 degree. This is T2 cos 53.1 degree. This is T2 sin 53.1 degree. And we know the vertical components will cancel each other. Okay, so sin 53.1 degree can be written as sin 90 minus 36.9 degree, which is cos of this. So T2 by T1 will be tan 36.9 degree, and tan 36.9 degree is this. So T2 by T1 is coming this. Okay, so now please watch here. What we are doing, since it is in equilibrium, that means let the center of mass be at a distance d from the left end. So this will be 2 minus d. Let the center of mass be at a distance of d from the left end. So this is 2 minus d. Clear? That means if, please watch here, I want to find out the rotational equilibrium at C. That means the rotational motion caused by this force and this force will be equal. That means this force into the perpendicular distance d and this force into the perpendicular distance 2 minus d about C, center of mass, should be same because the body is not turning. So this is the rotational equilibrium. Putting the value of cos 36.9 degree, cos 53.1 degree, we calculate the values and we get D. That means the center of mass lies at 0.745 meter from the left end. Next, Let us see this sum. A child stands at the center of a turntable. So a child is at the center of the turntable with his arms stretched out. The table is set rotating with angular speed 40 rpm. That means the table is rotating at this speed. How much is the angular speed of the child if he holds his hands back so that the moment of inertia becomes 2/5 of the original? Okay, assuming there is no friction. So please watch one thing. This was the turntable. The child was initially standing like this with his arms stretched. Now they are telling that it started to give a angular speed of 40 rpm. Now the child has closed his arms, folded his arms. So what will be the angular speed? The moment of inertia now is 2/5 of the original. So what will be the angular velocity of the child now? So we know that conservation of angular momentum. The angular momentum before and after would be same. Okay, so here omega 2 will be this. Now I2 is 2/5 of I1 they have given. So omega 2 will be 5/2 of omega 1. Omega 1 is already given. That means the child will now have 100 rpm. The angular velocity of the child will be 100 rpm. Now question is, show that the new kinetic energy of rotation is more than initial kinetic energy of rotation. Okay, so what was the initial kinetic energy of rotation? Half I omega. We know that kinetic energy formula is what? Half I omega square. So initially it was half I1 omega 1 square, and finally it is half I2 omega 2 square. So half cancel, I2 by I1, omega 2 by omega 1 whole square. So I2 by I1 is given 2/5, and omega 2 by omega 1 is 100 by 40 square, which is coming 6.25, and it is coming 2.5. That means the final kinetic energy is 2.5 times of initial kinetic energy. Now they are telling, since omega has increased, so definitely the kinetic energy will also increase. Clear? Let's see the next sum. The oxygen molecule has a mass of this. So we know oxygen molecule is O2. So there are 2 atoms of oxygen of mass is given to us, and moment of inertia of the molecule is given to us. It is rotating about an axis at the center. It is rotating like this about the center to the line joining the 2 atoms. The mean speed of this is given to us. The velocity of the particles is given to us, and kinetic energy of rotation is 2/3 of kinetic energy of translation. Find the angular velocity omega. They have given kinetic energy of rotation, which is half I omega square, is 2/3 kinetic energy of translational. Translation will be half mv square. So from there we are getting this. So omega is this, and they have also given that I omega square. So from here please watch one thing, that is, okay, so what we are getting from here, I omega square is coming 2/3. If I cut half and half, I omega square is coming 2/3. From here if I cut half and half, I am getting I omega square is this. So omega will be 2v square into 2m, putting the value of omega here, we are getting this. And now we put all the different values which I know. So this is the angular velocity of the molecule. This is the angular velocity of the molecule. Clear? So please watch here. Watch here one thing, that is here. So friend, let's see the next sum. Here, as you can see here, please, these are the two atoms M and M, and this line is bisecting it. So let the distance be R and R. So what is the moment of inertia? This is the moment of inertia. Total moment of inertia is this. So R will be this. Okay, this is the total moment of inertia. So here we are using the total moment of inertia, 2mr square omega square. We get the omega, and now we know that I omega square is this. Putting the value of omega, we calculate the angular speed of the rotation. Clear? Next, a particle describes a horizontal circle on a smooth inner surface of a conical funnel. So this is the conical funnel. Here is a particle, as you can see, here is the particle which will move like this, which is going to move like this. It is going to describe a path like this, okay, on the surface of the conical flask at a height of 9.8 centimeter from the vertex. Find the speed of the particle. This is the question. Find the speed of the particle. So let's see. If the particle is here, the weight will hang down. The reaction force is this. So if this is theta, that means this is also theta. So this is r cos theta. And this part, this force will be r sin theta, isn't it? This force will be what? R sin theta. So now let us see this. So r cos theta is balancing mg, and r sin theta gives you the centripetal force. So using it, tan theta, we are getting h by r. Tan theta, please watch here, tan theta is h by r. This is theta. So tan theta is h by the r. So this is the tan theta part. So from here we are getting tan theta equal to v square by rg, and tan theta is h by r. So using this relation, we are getting the v root hg. So that is the velocity of the particle. That is the velocity of rotation of the particle. Next, a tube of length L is filled completely with a liquid of mass m. So here is the tube L and filled with a liquid of mass m. Closed at both ends. The tube is then rotated in a horizontal plane. So this is how the tube is getting rotated in a horizontal plane about one of its ends. Okay, so this end is fixed. This end is fixed and it is rotated with angular velocity omega. Find the force exerted on the liquid at the other end. Okay, so please watch one thing, that is, this is the total tube rotated like this. So what is the force? The energy of rotation is half I omega square, rotational kinetic energy, which is force into the displacement. The force acting here be, let it be F into L. This is the work done. This is the work done is equal to the rotational energy. So from here, I is ml square. The moment of inertia is m into L square, because it is rotated along from the axis. From the axis, the length is L. That is, so the moment of inertia is ml square. So put the moment of inertia. So we get, this is the force acting on the other end. A uniform sphere of mass m and radius r is placed on a smooth horizontal surface. Okay, so as you can see, this is the mass m, radius r, placed on a smooth surface. The sphere is struck horizontally at a height. I am striking with a force. I am striking it with a force at a height h from the floor. Show that the sphere rolls without slipping with a constant velocity when h is 7r/5. So watch here. The turning moment of the force about the center will be F into h minus r, the moment. We can see here that the mass of the whole sphere is how much? M. Okay, and now what is the angular momentum about O? Angular momentum, that is momentum into the distance about O, is mv into h minus r, and angular momentum is also I omega. And for a sphere, the moment of inertia is 2/5 mr square, omega is v by r. From here we calculate that it is 7/5 r, h is 7/5. So angular momentum of the system is conserved. Angular momentum is momentum into the distance. So the momentum is m into v into h minus r. Okay, and v is the speed of the center of mass. V is the speed of the center of mass. So using this concept, we get the height of the, from where the force should be given. Next, a person decides to use his bathtub to generate electricity to run a bulb. Okay, so suppose this is a bathtub. From here the water will come out, fall on the generator. The generator will start turning. It will give us current, through which an electric bulb will be lighted. Okay, so here is the water in the tub. This water will be falling from here. The water will be falling from here, and due to this, the generator will start and produce electricity, which will light up the bulb. So they are telling the bulb is 40 watt. That means 40 joules per second is needed to light the bulb. It should get 40 joules in 1 second. Now the bathtub is at a height of 10 meter. That means, and it is holding 200 liters of water. They are telling at what rate should the bathtub, should the water fall so that the bulb gets lighted, and how long will the bulb be lighted on. Okay, so first of all, please watch one thing. 200 liters is the volume of the water. So liter to cubic meter is by 1000. So this is the volume into density. So this is the mass of the water. Clear? This is the mass of the water. Now I need an output of 40 joules. That means the generator should give me an output, but they are telling the efficiency is 90%. That means 90% of the input. This is the input. Please watch here. This is the input. This is the input, and this is the output. So I need 40 joules per second output, but efficiency is only 90%. That means 90% of input is 40. 90% of input should be 40. So what is the input? 44.4 joules per second is the output. Clear? 44.4 joules per second should be the output. Now that means the potential, and they are telling rate. the potential energy per second coming out should be 44.4. The potential energy out of the total potential energy, the potential energy which will start coming out will be 44.4 joules per second, because then only I can get 40 joules per second. So potential energy is mgh, so volume into density is the mass, into g into h should be 44 joules per second. So volume of water coming out will be this much cubic meter per second. Please watch here. That was their first question. How much water should come out per second? 4.5 10 to the power minus 4 per cubic meter of volume should come out per second. Now, time for which the bulb will be lighted. Please watch here. The total bathtub was having 200 kg. Okay, the total bathtub was having 200 kg. So what was the total output of the generator? What was the total output of the generator? 90% of the input. Okay, so 90% of the mgh, so 90% of m into g into h. This was the total output energy the bathtub can give. This is the total output energy the bathtub can give us due to the 200 kg of water. Okay, but the bulb needs only 40 joules. If this is the total energy given, but bulb only needs 40 joules, so till how much time it can run? So this divided by 40, 441 seconds. 441 seconds the bulb will be lighted on. Clear? Next sum, let's see. Two balls A and B of masses this and this are moving along positive and negative x-axis. Okay, so one is moving along the positive x-axis here, and one is moving along the negative x-axis. Both velocities 2 meters per second. They collide here and they again move back after collision. So let this be V1 and this be V2 after collision. Find their total kinetic energy before and after collision. Okay, find and the velocities with which they will return back. So we know momentum is conserved. So initial momentum m1 u1 minus m2 u2, because both were coming in opposite directions, this and this. So m1 u1 minus m2 u2 equal to m1 v1 minus m2 v2. Why? Because they both will again move away in the opposite direction. So putting m1 u1 m2 u2 m1 of v1 and v2 I don't know, so this is the relation of v1 and v2. Clear? Similarly, we know kinetic energy is also conserved. So from here, kinetic energy before collision is this and after collision is this, half cuts. Putting m1 u1 m2 u2 v1 and v2 I don't know, so this is that relation between v1 and v2. Now putting the value of v1 here, we get this. So now calculating it, we are getting middle term factor and solving it. This is 5v2 plus 14 and v2 minus 2 equal to 0. So solving it, we are getting v2 as 2 or minus 14 by 5. Now we will put v2 in this relation and get v1, which is 6 by 5 and minus 18 by 25. So these are the velocities of the particles of return after collision. Clear? So friends, with this we have discussed quite many sums here. at least I have discussed 23-24 sums of the chapters center of mass, moment of inertia, rotational motion, work power energy, and I hope you have understood it. But my thing is that please read the concept first before you see this. But I have tried to explain you in the most easiest manner, so my suggestion is, but please look into the theory concept of this first of all, then only you will be able to understand why I am taking these type of formulas. Clear? So this is all about for today's class. Hope you have understood, and if you have understood, please like, share and subscribe my channel. So thank you so much for watching the video, and let's wait for the next one.